Hello, everyone, and welcome to a new WAES Tech Talk. For those who do not know me, my name is Jenny, and I'd like to wish a warm welcome to everyone here in Eindhoven, but also a warm welcome to our colleagues in Utrecht, and of course, everyone who's watching on YouTube. So for today, we're going to have two presentations with three presenters. So first, Everton will tell you all about CPU limits on Kubernetes. He will share his experience and he will share his insights. And after that, Felipe and Jonathan will tell you all about the migration they did to Java 17 and Spring Boot 3, and they did that at Mozilla. So we have two presentations of about 30 minutes. After each presentation, you will get the opportunity to ask some questions. So for the people in the room, you can ask questions directly. And for the people joining on YouTube, you can ask the questions via the YouTube channel. So that's it from my part. Now I wish to bring Everton on stage. Enjoy, everyone.
Greetings. Hello, everyone. Greetings. The talk I'm going to do today, it's on CPU limits in Kubernetes. Our timeline is going to be, our agenda is going to be, I'm going to talk a little bit about me. We're going to talk a bit how the Kubernetes evolved over the years, specifically on the CPU limits feature, using it. I'm going to talk about the benefits and downsides. We're going to mention a little bit the kernel bugs and related features on the subject. I'm going to open myself for questions, but yet again, I'll try to answer them as best as I possibly can. So my name is Everton. I think my name was around here already. I'm a software engineer with experience implementing DevOps tools and practices. I have this passion for Kubernetes, as you can see on my shoulder. I have the Kubernetes tattoo, and I have managed Kubernetes clusters on GCP, AWS, and Azure. Another topic that I'm very passionate about is SRE, Site Reliability Engineering. It's a topic from Google, subject from Google, on how they manage their production service, their production applications. And the third thing I really like is cats. And I'm not sure if the cats really like me, but yeah, I do love them, truly, truly. Okay, so I would like to start rephrasing the title of my presentation to my understanding on CPU limits in Kubernetes. And the reason why I want to retitle is people are biased towards their professional experience, their personal experience, their companies they worked on. And this is the experience I bring with my professional, my personal, and the companies I worked on. So the Kubernetes, it is a fairly new project. It started in the fall of 2013 with three amazing Google engineers that they were astonished by the power of Docker containers. How are we going to manage the Docker containers in production? This was in their head, and they started to prototype an orchestrator that could handle that in really large scale. On the summer of 2014, Google released Kubernetes, announced it to the world that they built this incredible tool. And on July 2015, Kubernetes reached 1.0.0. That's a major achievement. We all developers know that when we reached the first major release, it indicates to the world that the project is stable and it can be used by others. One moment. It took a lot of time from enterprises to really embrace it, other than Google. And only on September 2017, Oracle joined the party. On October, Azure joined the party with their Azure Kubernetes service. And only on November 2017, AWS joined the party with their product as well. The reason why I'm showing you guys this timeline is you have to understand that Kubernetes is a new thing. It's like 10 years, 11 years thing. Not compared to Python that was invented way, way long ago. So things change, things evolve, and we're going to talk about the CPU limits. So when you first start reading and learning about compute resource management on Kubernetes, you're presented with a very well-written documentation which explains you the usage of this block. It's called resources. And inside the resources, you can specify limits and requests, either for CPU and memory. We're going to focus only on the CPU limits, but yet again, all the configuration here is very important, and they enable you to use other features of Kubernetes. When I was reading this documentation, I was astonished by the amount of details that the documentation provides. And in the documentation, it shows an examples using limits. So back then, I thought, okay, it is in the documentations. It must be a good practice. And this is what I did with all the customers, all the deployments, all the companies I worked on. I put CPU limits and just let it happen. This is how I felt when I read the documentation. It's there, so it needs to be used. But what actually happens if you use CPU limits? If I want to show you guys what actually happened under the hood, it would take like a 3 hours presentation, going deep down into the kernel level and how that is implemented on the Linux. But I don't have time, and also, this is deep knowledge. So I want you guys to understand as simple as the feature is read. If you put a limit, then you won't be allowed to use anything above that limit. And the underlying operational system will apply what we call throttled. So your application will be throttled if it reaches that limit, right? Okay, so I mentioned that we rely on the operational system to implement the CPU limits feature, and on Kubernetes, we rely on the Linux kernel. The Linux kernel, as I'm showing here on the screen, it's the top one highest velocity open source project in the world. There are lots of contributions, a lot of changes, a lot of things happening on this project, and Kubernetes relies on it to implement the CPU limits feature. Kubernetes is very close to Linux, but it's not there yet. What I want to show with this is you can expect that sudden changes can occur on the Linux kernel that would, in fact, affect your Kubernetes feature, like the CPU limit. And it did, right? There was a kernel bug that affected the CPU limits, and it was unnoticed for many, many years. But we're going to highlight that later. Right now, I want to talk about the benefits of using CPU limits. And I don't want to talk about me, and I want to talk about people that went public with their own explanation on CPU limits. So I found this guy. His name is Denilson Anastasio. He's an IBM employee for over 25 years. He wrote a nice blog on why you should use CPU limits. He has a lot of reasons. I'm just going to highlight a few. First one is he states that you should accept throttling on your application. Live with it. Accept that throttling is like a nature of your application, and build it as reliable as possible to live under throttled. That is a really good suggestion, right? Not only for CPU limits, but we should apply that to all. And he also states that you should not rely on available idle resources on your host. You should instead rely on pod autoscalers. It doesn't matter what strategy you use, but they can do a better job. So he highlights the horizontal pod autoscaler, the virtual pod autoscaler, and I'm also putting here the Kubernetes event-driven autoscaling project, which I like the most. All right, and the third point he mentioned is the guarantee status. The guarantee status, I will have to explain a little bit more on how it works because it does interact with another feature of Kubernetes. But basically, if you have resources and request equals, then your pod will be granted guaranteed status. And with guaranteed, you have some additional perks on the Kubernetes scheduling and prediction. So I'm going to show that. This is the pod definition that has no compute resource management. Kubernetes will give it the status as best effort. The second example, it's a pod where we specify requests for CPU or memory, and Kubernetes will consider this pod burstable. It will grant these available resources during scheduling, but it will allow it to use as much as the host has. And the third option is the one where you define CPU limits and CPU requests, and they're both the same value. This will grant your pod the status of, as guaranteed, and guaranteed, as I mentioned, it has some perks during scheduling and eviction. By having guaranteed, you also enable another feature, which I will mention later. Now, going back to the downsides. And the downsides was much, much easier for me to find people on the internet advocating for not using CPU limits. But let's try to elaborate on that. In my understanding, one of the downsides is the feature itself. When you apply a CPU limit, your application will be throttled if it reaches that limit. So if you do not build your application, if you do not test your application, if you do not put your application with real traffic and understand how it works on the throttling, then throttling will have a major effect on your application. And then also, if you specify a limit, you will not be able to use available idle resources on the machine. What I have seen from companies is their hosts on the Kubernetes, they have like a really fatty 60, even 70% of available CPU, which is not being used, and they will not be allowed to be used if there is limits in place. And that has a huge impact on low latency applications, especially those that have high throughput traffic, and maybe sometimes the traffic is not as stable as it looks like. It's burstable, and your application might just need a little more of CPU to handle all those requests in an acceptable latency, but you got CPU limits and you won't be allowed to do that, and you have higher latency. All right, one sip of water. And people went public with their own opinions. I want to highlight this man. His name is Stephen Hawkins. He's a Google engineer as well. He joined Kubernetes back then in 2014. And he posted Twitter saying that most often you just set CPU limit to none, just don't use CPU limit, and set your memory limits equals to your memory request. This will handle majority of your workloads. He also states that you should reconsider his words always and never, and we're going to talk about that later. We have Nathan Yelling. He's a really good community member on the open source and the monitoring on Kubernetes. He also wrote a nice blog explaining why you should not use CPU limits. And I recommend you all to have a look on this blog. I myself went public as well with my own opinion on do not use CPU limits, but my words were not kind enough to put on the slides, so I'm just gonna not put it over here. But you have to understand, colleagues, that those people went public and I went public because we saw with our own eyes. We saw the feature not working as expected. We set a limit, our application was not reaching that limit, but we still being throttled. I saw that on my own performance testing, and on my own performance testing, I decided to remove CPU limits just to see how it goes. Results were much better. I'm going to showcase here on the screen a colleague that went on the GitHub and posted their results. When they completely removed the CPU limits, their ingress controller got latencies 20 times X lower. That's a huge achievement, especially for ingress controllers, which are so critical on the Kubernetes. And again, my personal experience, I got very excited about the subject when I watched the presentation from Henning Jacobs. Henning Jacobs, well, by the time he was a Zalando engineer, I'm not sure what he does now, but he presented this CPU limits feature in deep details and how it interacts with the kernel and why they decided to remove CPU limits and how did they disable CPU limits on their production cluster. And he pushed the community. He went public. He showcased their results, and the results were massive. By removing CPU limits, they reduce their latency, they achieve their SLOs. And one of the things that I really like that 𝐻𝐻𝐿 was able to accomplish is he pushed the community to disable CPU limits, but actually he pushed the community to allow you to configure the way you want. So one of the achievements I'm highlighting here on the screen, right now today, you're capable of defining the CFS quota period parameter directly on your cloud Kubernetes clusters. And that was a major achievement. And in my opinion, it was because 𝐻𝐻𝐿 went public and tried to fight with people on disabling CPU limits. It's really advanced, but we can talk about that in questions. All right. And for me, the second achievement of 𝐻𝐻𝐿 was, let's go public. Let's discuss. Let's see if there is an issue. And an issue was found. They found an issue on the kernel. So yet again, the Kubernetes relies on the kernel to implement limits, and they found a bug on the component that implements CPU limits, that implements the throttling. It's called CFS complete flare scheduling, if I'm not mistaken. Amazing. The community went and just fixed this bug. But unfortunately, another bug was introduced when they fixed the bug. So some users, really high-skilled, they patch their Kubernetes servers, they run performance testing. And I want to highlight here David Chillock. At the time, he was an Indeed engineer. Right now, I'm not sure what he does. But he mentions here that Java workloads, especially on high core count machines, they see highest amount of throttling, even though they're not reaching their limits. Again, the same thing I was facing with my applications back then. I was not reaching the limit. Why am I being throttled? It was a kernel bug. So he saw performance degradations of roughly 30x. And then David went public. He posted a really nice presentation where he explained how the feature works, how the kernel interacts with the feature, what happens after the kernel was fixed for the first time, how the bug happened after that fix. And again, he proposed a new fix, and the fix got merged back into the kernel. But I want to highlight here the dates. We are on August 8, 2019, where the change, the fix on the kernel, almost reached the Linux tree. But you guys know that lifecycle management is a thing that it doesn't happen from the day 1 to the day 2. It takes a while. The cloud providers still needed to test this kernel patch. The cloud providers still needed to distribute this fix across multiple customers, and that takes a while. It took a while from me. I was affected. And then after multiple upgrades, I saw that the kernel was fixed on my clusters. All right, so how about now, today, 2023? Are you affected? For this bug, most likely not. So don't worry, it is a safe feature, although you will be throttled. So, okay, I want to talk about related features because they are very important on the CPU limit scope. The first feature is the CPU manager with the static policy. This is quite new on Kubernetes. It went stable on the 126. We're now on the 128. Some of the cloud providers are not on the 28, so 126, quite new for a lot of people. Well, what this feature allows you is to have exclusivity of CPU for your application. So what do you mean by that? There are some applications that benefits from CPU exclusivity. And in the past, Kubernetes did not have a native way to assign 2 dedicated cores to your application. It doesn't mean that if you put request to 2, you get 2 cores. With the static policy on the CPU manager, you get that. But there is a catch. Your pod needs to be guaranteed. And in order to have guaranteed, you need the CPU limits. That goes all the way, not against my recommendation, but let's discuss that later. The second feature I want to highlight is the in-place pod vertical auto-scaling. This is quite new. It is not stable yet, but this feature will allow your application to dynamically change your compute resource management without having to restart the application. That was a major downside of having to manage CPU limits, CPU requests, memory limits, memory requests, that if you apply a change, you have to roll out all your pods, all your applications. With this feature, you don't need to do that anymore. Kubernetes will change this configuration, and you won't have to roll out your pods. This is especially useful for Java applications where they have the startup of their application that consumes a lot of CPU, but after then they just go like very low CPU usage. This is a very cool feature. I'm eager to try it out. Yeah, there it goes. This is the feature definition. Okay, colleagues. So I just want to finish with this. Yeah, okay, Everton. You told a lot of things to us on the CPU limits, how it works, the kernel bug, and okay, should I use it or should I not use it? It's not up to me to define if you should use it or not. It's up to you because you know your business, you know your criticality, you know how you want your pods to be scheduled. So you define together with your team what are the requirements and just go with it. What I can say from my side is I have completely removed CPU limits on many of my customers and being able to manage a really stable SLO without having further implications. But there are situations where you need to use limits. For example, misbehaving applications. That is the worst case scenario. You deploy an application to your cluster, and suddenly the node that your application got deployed goes down because that application consumes all the available CPU resources. So it's a safe feature. It is there to be used. Use it if you need it. This is my recommendation for you. And I'm also going to put here, colleagues, this very nice tooling, which provides you dynamic recommendations based on your Prometheus metrics. So you plug that in your Prometheus cluster, it will fetch, do some analysis, and it will provide you recommendations on CPU limits, CPU requests, memory limits, and memory requests. This is open source. Thanks, Nathan, for that. And I really recommend you guys to have a look on it. All right, colleagues, that's my presentation. I'm open for questions now. Thank you all. Thank you all. Questions? Let's see. There's something.
You mentioned one of these features was without the need to restart the node.
Yes.
For especially beneficial for Java applications.
Absolutely.
I wonder whether the Java application itself does it need to use Quarkus or anything.
Okay. So I'm going to repeat your question so the people that are online can see it. He mentioned about the in-pod changes, dynamic changes on the resource, and how Java interacts with it, and if you need Quarkus to have that feature, right? Well, it is still a new feature, so it's very hard to find people playing around with that. What I found is people using raw Spring Boot, and it's just working fine. But again, it is not a stable feature yet, so you will not find that on any cloud providers, not by like default, right? You have to enable certain feature flags, which might or might not be available on your Kubernetes. But what I saw is like available for all. It doesn't matter if it is Java, Python, C, Go, it doesn't matter. Nice. Yes, please go on, my man.
From our experience, because I really like that you mentioned that Linux kernel changed a lot and they're really reliable, but the interaction with Kubernetes and the Linux kernel, it's really intrinsic. For our experience, what do you think about, okay, any new fix or changes in the kernel would affect, again, the CPU limits or maybe other stuff?
Yeah, colleagues. So let me give you some understanding of what's happening right now. There are multiple issues on the Kubernetes GitHub of people saying, please help me, I'm being throttled. And we don't know if they're being throttled because of a kernel bug or because their application sucks. So we got to balance, you know, we have to have those amazing community colleagues that go deep into the kernel level to analyze. What I know so far, it hasn't have any confirmation of a bug on the kernel right as 2023. But who knows? it's a fast evolving project, like the top one highest velocity, anything can happen, right? But we have Linux Storvort always there, keeping his eye open. It's not gonna have some more bugs. I hope it doesn't. No problem. All right.
No more questions in the room?
Thank you all.
Okay, wait, I have one.
Oh,
I have
yes.
one. Actually, you got some great response.
Oh,
so,
yes.
Yeah, that's really good. No questions on YouTube, just one poll that they started.
Oh, Jesus.
And the poll was, who wants to see Everton Kubernetes tattoo?
Oh, yes. No way. Yeah, colleagues. So this is my Kubernetes tattoo. I put it on my shoulder to make sure that I got all the Kubernetes certifications. And thanks to WAES, I got the 2 certifications of Kubernetes. So thank you so much. Let's rock it, colleagues.
Nice. Okay. Thank you, Everton.
No problem.
Then I would like to welcome Jonathan and Felipe.
Yeah. Hello, everyone. Yeah, my name is Jonathan. Felipe is setting up the mic here. But today, we both are going to be talking about the Java 17 migration and the Spring 3 migration. We migrated from Java 11 to Java 17. And the Spring Boot was 2.6. And in the end, it ended up as a 3.0. And yeah, we're gonna explain, of course, who we are. We're gonna go over our environment and all the tools that we use. Why we choose to migrate, why we decided to migrate, and how we planned and executed it. Yeah, we're gonna go over the tools that we use it, the problem that we found, and in the end, we're gonna leave some useful links that you guys can refer to improve your applications. Yeah, so starting with who we are. My name is Jonathan. I'm a software consultant at 𝐉𝐨𝐧. I've been a backend developer for the past almost 7 years. This is my family, my son Peter, my wife Chris, and I love watching football, be with my family and friends, grab a couple of beers. So yeah, please reach out if you want to talk about anything.
Well, hello, I'm Felipe. Felipe Flores. I'm also Brazilian. I'm also a consultant at 𝐉𝐶. I am also a GCP architect, although right now I'm working with AWS. So topics that I really love are burgers, beers. I really love comics and code. So yeah, if you want to get in touch, just ping me. And my family,
Sorry.
just a second. And these are my family. So Carolina, my wife, and my kid, Heitor, which is 1 year old now. And yeah, great. So let's talk about our environment. I think this is a really important part of the migration, because depending on how much or how easy your environment and your cluster or everything related, it will play a really big role on what you're doing. I can go from here.
Yeah.
So first, one thing that makes things a little bit easier for us and during the migration was that we run our cluster on EKS. So you can think of Kubernetes, and everything is Dockerized. So that's really easy to just do step-by-step and service per service migration. We don't need to do a large migration. So yeah, that was really helpful. Secondly, of course, we are talking about Java and Spring. So Java 11 at the time, and Spring was 2.76. And then, yeah. So we have also other kinds of services like Python and TypeScript and Node.js in this case, but and they needed to keep still working. So this plays a little bit of a role. But we are talking about the Java and Spring repositories. Of course, we also don't do everything by hand. Like we have a CI/CD in place using Bamboo. And we also do some observability using Datadog. So we can have our logs, metrics, and everything there. Well, this is our setup, but you can also ask me, how big is it then? Because yeah, it could be 1 or 2 services, but yeah, actually we had 4 to 5 repositories to migrate, so it's not like a monorepo, a gigantic monorepo. We did repository by repository, and in this case, it's 45 repositories going. That means 32 services and 13 libraries. So it's quite big to do by 2 people, but yeah, we eventually got also help. But yeah, this is how large our cluster. Following, you could ask, like, why should we migrate then? Like, we have a huge cluster and things are working fine, so why did we decide to migrate? And there's a really important thing that was happening at the time. So Spring Boot 2.6, which I spoke wrongly before, was not being supported anymore. So it was getting out of LTS, so we wouldn't have any new patches and updates. So that was something that actually triggered us to do this migration. So this was important. We also had some other reasons. Those reasons are not actually pretty nice, but not really necessary. So we knew that the new Java 17 had also a new garbage collector, which improved a lot of response times and everything in the way it worked, but we didn't saw it working yet, so we wanted to test it. We also wanted to have new features from Spring Boot, like I could highlight maybe the native compilation. So this would be used in a couple of services, which we didn't use yet, but looking forward to. Also, being a nerd, code nerd, I really love the new syntax sugar from Java 17. We would like to try to improve code in multiple ways. So yeah, they can think of Java records, switch expressions, pattern matching, a couple of things that came with Java 17. And we didn't know at the time, but Java 11 is no longer as LTS starting from this month. So yeah, that's that. So lucky we already did this. Also, then it's nice to talk a little bit, how did we plan and execute this migration?
Yeah, so to execute this migration, like as Felipe explained, we have a lot of services, and like it wouldn't be easy to try it out. We had to make a plan and act on it. So we executed the migration in 3 phases. The first one, we migrate from Spring 2.6 to 2.7. The reason behind that, because that was the first one who could use the Java 17. So we made that change so we could later migrate to Java 17. So that was the phase 2. And the third phase, we migrated from Java 2.7 to Spring 2.7 to Spring 3. And how we did that? So first, we took the service that we knew the most, that we knew more about the business rules, and also service that had most coverage and integration tests. And I tried on those first because we could easily spot the errors that could be happening. So after, during this process, we documented everything that we found. So we created a Confluence page, and we started to putting everything that we found in the path, so we could avoid both actually fixing the same issue. So it was a way that we could communicate with each other and later show to the rest of the company. And we trusted the tests, but not blindly. So everything that we did, we checked our observability tools to see if they kept working as they should. And yeah, so we could verify that the migration went well. So yeah, let's talk about the results. What results we got because in the end, we are all about results, right? We need the numbers to show to the bosses and make our names. So yeah, so we found less resource consumption, so mainly memory. We could reduce drastically some services, the amount of resource, the memory needed, and in the end, it means less cost for the company that can be applied in somewhere else. Reduced latency. So for services that we had performance tests in place, we could perceive way better response times. So it's a good result. And more maintainable code base. As Felipe said, we have tons of new features in Java 17 that made the code more readable and easy to understand. So it helps us to maintain the code base cleaner and easier to understand. So let's show some numbers. So as I said, memory consumption, less costs. The heaviest service that I'm going to show here, it had 2.7 gigabytes in memory consumption. And after the migration, we could reduce to 800 megabytes. So it's using almost 30% of what it was using before. The lightest one went from 415 to 315, so 75% only. And the average services went from 600 megabytes to 407, so around 7-8% in memory consumption, which, yeah, it's less money, so we can spend in other developments for the company. The performance test results. So we can see here that the latency reduced drastically. I gotta assume that's not a really good service time response, I would say. It should be better, but we can see that it already reduced almost 50% of the response time. So yeah, the performance is indeed better. Let's talk about tools, because yeah, we don't have to do everything ourselves. And thanks to Bruno, he's watching on YouTube. He showed us this tool called Open Rewrite. This tool analyzes your code and make changes for you statically. It's not only for Java or to Spring migration. You also have other semantics analysis that you can apply. So it's good to take a look. The link is on the video description. And yeah, it will help you a lot. So let's show a small demo here. Let me just change it here. So I have the service running. As you guys can see, it's Spring 2.7. And I can come here just to show that it's working. Just a dummy project, so doubling some number to became 4, which is not showing there. I don't know why. Let's see if I can make it a little bit smaller. Ooh, sorry for that. Whoa. So let's see now. It's not showing. Believe me, it's showing a 4 and a message, but you can see this is another message and multi-line. So I'm gonna stop the service here, and I'm gonna run this Maven. They call it recipe, and you can put what sort of migration you want to execute. In this case, I'm just running Java 17 and Spring Boot. It takes around 1 minute to run. I'm gonna leave it running, and I'm gonna show you, keep showing you guys here. I'm gonna do a quick disclaimer. Oh no, come on! It wasn't the proper slide. So sorry for the technical. Yeah. So quick disclaimer. Really? Let me just try to. Yeah. So quick disclaimer, guys. What happens is you can use those tools, but don't trust it blindly, because they can introduce behaviors that you're not expecting. So please verify everything that the tool suggests to you. Also, you don't have to accept all the changes. If the tool suggests something that you guys think that's not worth applying, please avoid it. You know your context better than anyone. So yeah, and now I'm going out again. So yeah, yeah. The tool executed as expected. So we can check here, for example. I think for the sake of you can visualize better. We can see here that the tool changed. For example, the POM, it went from 2.7 to 3.1. The Java version also added some dependencies that if it finds that's necessary, you can verify if it's necessary or not. It make changes on the controller, and it not only changed the necessary stuff, like for example the Jakarta package, but also do some syntax, like this auto-wired here is not necessary, so it remove it, and you can keep it or not depending on your code style. Yeah, and here some Java 17 demonstration. So we had the instance of here where we need to cast, and now we have, for example, the instance of with pattern matching. So we don't need anymore to cast stuff. Also changed some string that was being concatenated to a multi-line string. So just a small example here, so you can have a gist of it. And just for the sake of showing that everything is working, we can run again the services, and you'll see here that's with Spring 3.1 now, and the API is still working. So yeah, and slideshow. Oh. Ah. Yeah, sorry for that. Which one? Play from current slide.
Just a second. Yes. So, yeah, good at doing migration, but not as much as
PowerPoint.
PowerPoint is kind
That's not our skill.
Yeah, we're going to talk a little bit about the problems that we had. Nope.
Problem. Good.
Great. Yeah, before even going to the problems, you can find this small project on GitHub, on the WAES GitHub. There's the code is there. Yeah, we can also share it later. But yeah, let's talk a little bit about problems then. Yeah, it was not really easy. Not everything was just run the tool. And you can also see in the demo that it didn't change the switch expression. So there are a couple of things that are not covered. So if you want to do that, it's not required. But if you want to do that, you can do that yourself. So we had a couple of problems. Remember that I said that I really like the syntax sugar on Java 17, and sometimes we thought without checking really into the new syntax, that things were just a new and cleaner API, and sometimes it's not. So we had this issue with the new string to list, which at some point you could do like a collectors to list, and this creates a mutable list, and eventually, in some place in your code, you do some mutation that list. Of course, you would agree with me that's not a good practice. You would like to have a immutable list, but that's not how it was before. So if when we changed a couple of things to list, imagine that it would be like just a cleaner API, and some errors start to pop up. Of course, if we did have some unit tests in place, then it would be caught. But yeah, if you stop to think about it, if doing mutation is already a bad practice. I wouldn't expect it to be covered by tests. What else? We have a new constructor to collections. So we have a list of, and what I'm going to talk about also stands for set off and map off. Previously, we could do the arrays as list, and it accepts a null. But yeah, right now the list of doesn't accept a null, and that stands for the other constructors as well. You could also argue that this is pretty in your face, so you would notice. But you can imagine that this null could also be a variable or some function call, or that might return, might not return a null, and yeah, you would just have a error in your face. Again, if you had a unit test for it, a small unit test for it, it would be safe to just just fix it. But in this case, also a bad practice to put null into lists of complex objects. Yeah, it wasn't covered by tests. So yeah, we had some issues. Of course, to revert was pretty simple. It's just use whatever you're using back then, because yeah, this is still supported. But yeah, and the worst part in this case was if we didn't have the unit test, we just caught that during observability time. So yeah, not a really great place to figure out this stuff. Second thing that we had, and it was more on Spring Boot or Spring upgrade, is that the new Spring security thing changes a little bit, but not just it's not clear how it changes. Like we were observing how the service was working, and eventually the code took some path, and we started getting a lot of 401s. And it was not really easy to track. Like the classes on Spring Security that changed, we had done the new configuration or changed to the new ones. The tool actually helped with that. But one thing that the tool didn't help is that because the new Spring Security, you don't have the OAuth template, REST template anymore. Now, and this was set up by the Spring Boot, and you didn't have to do anything. Now you have to dump this huge configuration. So yeah, it's easily fixable, because it's just although it's huge, but it's a simple configuration. You just have to instantiate the new web client. But you have to do that now, and before you didn't. So that was a pain. And again, if we just had like a simple with mock user test, that could have been avoided. So it's pretty simple to avoid, just adding a new test. But yeah, we didn't have that. One last thing, I'm talking a lot about adding tests, but there are cases where we were pretty sure because of a service, because the service was full of integration tests, and then in this case, those services used Postgres as a database, and we had integration tests in place, and then we run everything was fine, and we were pretty safe, and then we hit the deploy button to test, of course, not to production, and we start getting some errors, and yeah, after checking, like, yeah, well, every integration test is fine, but what is happening? It's using H2, so not using the real database, and then things change if you're testing against the wrong thing. So now we also want to thank Fabrício, because he used a lot of test containers to help this. So we used actually run the test against the real Postgres database. And yeah, if you don't know how to do that, please refer back to his post and Tech Talk. So this was really helpful, and yeah, very nice indeed. We also used that for InfluxDB and a couple of other things, so that was really helpful. We had a couple of other minor issues, but they are really well documented. I think in at least one of the links on the description there are how to solve it. So flyway, new version, there's a little bit of configuration. Usually this stuff is solved by just minor configuration, not really touching code. Not so much for Spring I/O and OpenAPI. I have to change it, but a bit of, I'd say, annotations. Hibernate 6, which also just a few configurations, and it's closely related to the Postgres thing that I just mentioned. And new Spring security classes. Then the tool, OpenWrite, really helped with that, so we didn't have to change everything by ourselves. So that was really great. So as we said, there should be some useful links on how to do the migration and how, everything was played out. Like explaining a little bit about the new garbage collector and new Java 17 features. So yeah, you can have a good time reading it. And I think that's it. So just a quick conclusion. What is nice to take away from this is that we did touch the code by doing a couple of the new features on the Java 17, but we didn't need to do that. So you can have the nice results on memory, on response time, only by doing the migration of Java 17 and eventually Spring Boot. So you don't need to really go into changing everything. So you can take it even more and more smaller steps if that's required. Yeah. And yeah, this was done in a real environment. So
yeah, another takeaway is like if you plan and execute it in phases instead of trying to do everything and try to document as much as possible, it will definitely save you a lot of double work, I would say. So we saved that a lot of time sharing these ideas through the documentation that saved us a lot of trouble along the path. So it's really important to document and plan how you're going to execute it.
Yeah, that played a really big role in safety, and saved a lot of time for us.
Yeah.
So yeah, we can have your questions now.
Are the performance of the application, the update to Java 17 or the update to Spring Boot?
Java 17.
Yeah. Just repeating the question for the people online. A consultant asked if the improvement in the performance test, if we feel that the improvement was more related to the Java 17 migration or to the Spring Boot, and I can say that the Java 17 played the biggest role on that, mainly because of the new garbage collector. It has new features that improve the performance of the garbage collector. And for example, this application that had this huge consumption of memory, it has a feature that it loads basically a database into memory and do some calculations and then dumps it out. And before it needed a lot of memory because it stayed on the memory for more time than necessary. So yeah, the Java 17 played the biggest role.
Yeah,
definitely.
You can think also on the latency improvement, because the garbage collector runs less frequently but more efficiently. It also doesn't take much time of the response time. Yeah, so that's a really good thing. So we to be fair, we didn't use we didn't use any native compilation yet, so that could also mean even more benefits. But yeah.
Thank you for your question.
Following up on the question, do you feel that just like by upgrading the JVM, maybe you could already have those benefits, or would you have to really update the code to Java 17?
Okay, so the question was if we just upgrade the JVM, it would already have those benefits, or if we needed to do the coding improvements. So the answer is yes. Just does the JVM would be okay, because the changes that we did on the code was more of a syntax thing, sugar. So more cosmetic than yeah. So it will mostly due to the new garbage collector and how things play together.
So you guys mentioned that. Sorry.
No, go on.
You guys mentioned that it was 45 microsites to be created. So how much time did it take to do this whole migration?
Yeah. So the question here is about how long did it take to do those migrations, and it roughly took like 1 month about each migration. So first migrated the Java, then the Spring. I mean, like the Java 11 to Java 17, and the Spring 2.7 to 3.0, and it took roughly 1 month each.
Yes. Yeah, you can imagine that most of the time was getting the process right, and after we got this right, then we could roll out a couple of them like really quickly after.
Yeah.
You mentioned the environment with Docker. It is really good, but it's still looking for the DevOps dark side of the world. Still you need to build. Maybe you need to have build servers or any kind of servers involved in the CI/CD process. Did you face any issues of that, or was everything already configured? Or
okay, so the question was about how the upgrades that we needed to do on the CI/CD pipeline. Do you want to take it?
Yeah, mostly we had to change the Docker image that we use it to build and to deploy. So we had a DevOps team taking care of that. So we did the change. Also some configurations on how we configure the Java heap space and everything, but nothing to have on our end, I would say.
Yeah, it was in some sense, because we used Bamboo, and Bamboo has a Bamboo agent that's the one who does the building, and it's also Dockerized, so we needed to update that. Actually referenced an agent that's Java 17, and that was basically that.
Yeah.
We have no questions on YouTube, so I would like to finalize this tech talk. Everton, can you come up as well? I would like one big applause for our presenters. Oh, we got some presents for you.
Oh.
We got some nice, really interesting.
Oh,
there you go.
Thank you very much.
Thank you, Al.
Thank you, and thank you for the great presentation.
Thank you very much, guys. All right. All right. I should do it more.